Welcome to Homework Lib.
So here we have the circuit, and if there is an ohm meter that is connected in between these two terminals A and B, so what effective resistance will it read? Because we know, guys, the ohm meter measures the resistance, in fact the total resistance across the 2 points. So here, if ohm meter is connected, let us arrange the circuit. So consider this point having potential B. This will also have potential B. Here also B, because potential remains unchanged across a connected straight wire. And let's say this point is C. This is also C. And this will also be C because they are all connected. And this point will be having D. So let us rearrange. Between A and B, we need to figure out the resistance. And later on, we have this 10 ohm. So between A and B, we have 10 ohm. Let's connect it. And then between A and C we have 7 ohm. So let's say this is C. So we have 7 ohm here. Between B and C we have 60 ohm. So this is B and C. Again, between C and D we have 20 ohm. So there is another point D. So let's say this is point D. So between C and D we have 20 ohm. And between B and D we again have 45 ohm. So we had 6 resistors. So 7 ohm, 60, 30. This 30 ohm, that's between B and D. So between B and D, we have one more 30 ohm. So that will be connected somewhat like this. So first we can observe, I'll need to condense these two connections because they are in parallel. So we'll apply 1 by Rp as 1 by R1 plus 1 by R2. So considering R1 and R2 as 45, so across B and D, the total resistance here in this case 1 by Rp, we take the LCM here for 45 and 30, so we get 90. So we get Rp here as 90 by 5, that is 18 ohm. So again we modify the circuit here. So we had the 7 ohm, we had the 60 ohm, we had the 20 ohm resistor here, and then we had here 18 ohm, and here we have 10 ohm. So we are figuring out the resistance between A and B. So across this A and B we are figuring out. So these two are in series, so they will combine and the total resistance will be 20 plus 18, that is 38 ohm. So again the circuit modifies here. We had this 60 ohm resistor, and then in parallel we had this 38 ohm resistor, and then we had this 7 ohm, and then here we had finally 10 ohm across this A and B. So these two resistors in parallel, the total will be 60 times 38 over 60 plus 38, and then it will be in series with this 7 ohm. So computing this total value over here, 60 times 38 over 98, and we add 7 to it, approximately we get 30.26. So across this A and B we had 10 ohm resistor, and then this 30.26 is connected in parallel. So an ohm meter connected across A and B will read the resistance equivalent to 30.26 into 10 over 30.26 plus 10, because I'm just using the effective formula to get the resistance in parallel, that is R1 R2 over R1 plus R2. So this will come out to be here 342.9. So approximately 343 ohm is the total resistance read by the ohm meter.